Hi, this is a project about Kafka and Strong. This is an introduction to the Kafka and Strong. So what is Kafka? So we have learned about the Hadoop and big data and other technologies. Most of the technologies are, so far we have learned, is regarding batch processing. Most of the batch processing means they're not in real time, which means the last part of the data analysis is left out because you are working through the previous or historical data, maybe by a day, by a few hours, or by a few minutes. But that's what happens with the batch processing. So the Kafka and Strong together allows us to manage the real-time data processing for a large data set. So what do we need for that? We need two things. One is a very robust infrastructure for messaging, and then robust infrastructure for processing the data. And that's what Kafka and Strong provides. So Kafka is a publish subscribe mechanism, the standard one, as you know, and it is written in Scala language. It is very scalable language, using more recent days. Um, and Kafka removes the limitation because it provides this real-time integration for the stream processing. Many companies uses that, including Facebook's Project Scribe. Um, so does the Kafka provide? So Kafka provides four main things. One is persistent messaging, high throughput partitioning, and parallel data load in Hadoop. Um, Here is how it is deployed at LinkedIn. So it's mainly used for the log processing. So you basically have these different services which provides the data to the queue in the Kafka, and Kafka writes the data into the offline data center using the messaging structure and feeds to the Hadoop. As you can see, there are some stats available, which I think it processes around 10 billion messages per day, which is quite impressive, and reads 50 billion messages per day. So that's one of the implementation of Kafka. Here is a different slides from LinkedIn in terms of how Kafka is used. Um, so they have producers which produces a message. It goes to the broker and it's consumed by the consumer, which is all managed through Kafka. Zookeeper will learn about that later, but that's mainly the technology which manages the configuration uh, among different machines on your cluster. We will learn about that. Now, here is a simple Kafka API at a very high level. So as I mentioned, it's a publish subscribe mechanism. So there is a producer and there is a consumer. So producer produces the messages and consumer consumes the message. How do you install the Kafka? Kafka is available in Apache license, and you can download the version and you can just untar the file, just put it in the places where you want to, and keep that in your path so you can access the Kafka executables. There are two configurations as expected, one on the server side and the client side. On the server side, actually it needs to understand the flush at the specific timeouts. I mean, you can flush the data, and there are two ways you can do that. One is that the specific timeout or specific number of messages. On the client side, basically there are other settings which, how much compression you want to do, or either it's a sync or async operation. It's pretty interesting in that area. And there is a batch size and fetch size. So that's kind of the configuration for Kafka. Now this Kafka messaging is used for the Strong. Strong is actually a distributed real-time computation system, as you can read from the slide. Anyway, so Strong basically is real-time Hadoop. It's basically take the stream of the data, massage the data, and sends the data out to another stream or other machines to process further. It has four main areas: streams, parse, goals, and topologies. Streams actually is made of tuples, which is set of data. Sparse is basically sources of streams, so where the data comes from. So you can connect these sparse in a different way. Reads the data from queue like Kafka, things like that. And the bulls are actually what makes interesting in terms of, it's like a Unix pipe command. I wouldn't say it's a pipe command, but it's like a Unix pipe, which lets you transform the data in the real time. It can have the functions like functions itself, and You can execute the functions for you. You can do filters of the data, join the data, aggregation data in the real time. And the topology is just you put all these together and create this topology. If I can say other way, it's more like a workflow across different points. Here's the strong topologies in a figure from Project Strong. Here is a small example about a bold, about how the bold is written, which basically this is just a declaration of the tuple. Alright, how to install Strong? That's pretty straightforward. You can go to Strong projects and download the your Strong data or binaries. Um, and you may want to install Zookeeper. Zookeeper is actually, as I mentioned, it does maintain the cluster and makes it easier to maintain, like the naming convention, the configuration management, the synchronization of the configs, and other group services. So that's kind of what Zookeeper does. Zookeeper has its own interesting stuff. So the main node, the strong, is called Nimbus. It's just like a Hadoop job tracker, which is distribute code around the cluster. And then each node has a supervisor, into your cluster. So the coordination between this main node, which is Nimbus, and supervisor is